Hello friends, and welcome back to Webronaq. In our last video, we looked at a simple C program to check whether a number is prime or not. Today, we're going to level that program up. This is an upgraded version where the program doesn't just give you a yes or no answer. It actually shows you what's happening behind the scenes, step by step. You'll be able to see exactly how the program is thinking as it checks each number. So let me walk you through it. All right, let's start from the top. Lines 1 and 3 are the same as before. We include the standard input and output library, and we start our main function. Nothing new here. On line 4, we declare our three variables, n for the user's number, I for the loop counter, and isPrime set to 1 as our flag variable, assuming the number is prime until proven otherwise. Lines 6 and 7 ask the user to enter a number and then read it into n, same as before. Now here's where the upgrade starts showing up. On line 9, we check if the number is less than or equal to 1. If it is, we set isPrime to 0. But look at line 11. This is new. We're now printing a clear message telling the user exactly why the number isn't prime. It literally says this number is not prime because it is less than or equal to 1. See how much more helpful that is? Instead of just saying not prime, the program is actually explaining its reasoning. That's the whole point of this upgrade, to make the logic transparent. Now, moving to the else block on line 12, we enter our for loop on line 13. Just like before, we loop from 2 up to half of n, because that's the smart, efficient range to check for divisors. But look at line 14. This is another big upgrade. Before we even check whether the number is divisible, we print out what we're currently checking. The message says something like checking 15% 3 equals 0, where the double percent sign is just how we print a single percent symbol in C. So the user can actually see each division attempt happening in real time. It's like we're letting the viewer peek inside the program's brain. Then, on line 16, we do our divisibility check using the modulo operator. If n%i equals 0. If the remainder is 0, that means I divides n perfectly. And here's where the next upgrade kicks in. On line 17, instead of silently flagging the number as not prime, we print a clear message saying this number is divisible by this value, therefore it's not prime. Then, on line 18, we set isPrime to 0, and on line 19, we break out of the loop. This is so much better for learning because now you can actually see which number caused the failure. You don't just get a verdict, you get the reasoning. Now, moving down to line 23. After the loop finishes, we check our flag. If isPrime is still 1, we print a nice message on line 24 that says, no divisors found, therefore this number is prime. Again, notice how it's not just saying prime, it's explaining why. And finally, line 28, return 0, closes out the program like always. So let me quickly sum up what makes this version special. The original program just told you whether a number was prime or not. This upgraded version walks you through its thinking. It shows you every division it checks, points out exactly where it found a divisor, if there is one, and clearly explains its final decision. Why is this useful? Well, two big reasons. First, when you're learning to code, being able to see what's happening step by step makes everything click much faster. You start to understand not just what the code does, but how it works. And second, this is actually a really important debugging technique. When your programs get more complex, adding these kinds of print statements helps you figure out what's going wrong and where. Experienced programmers do this all the time. Let me give you a quick example. Say the user enters 15. The program would show checking 15% 2 equals 1, no match. Then checking 15% 3 equals 0, match found. And then it would print 15 is divisible by 3, therefore not prime. Simple, clear, and super educational. But if the user entered 7, the program would check 7% 2, which gives a remainder of 1, then 7% 3, which also gives a remainder of 1, and the loop would end. Then it would print no divisors found, therefore 7 is prime. You can literally follow the logic with your own eyes. So that's the upgraded version, friends. Same core logic, but with way more visibility into what's happening. This is honestly how I recommend you explore any program you're learning. Add print statements, watch the flow, and you'll pick things up much faster. And that's a wrap on this video. If you found this helpful, please hit that like button, share this video with a friend who's learning C, and don't forget to subscribe to Webronaq for more beginner-friendly programming tutorials. Thanks so much for watching, and I'll catch you in the next one. Happy coding!